Hello, good day, students. This is Mr. Matthew. I'm here to present a topic in mathematics, volumes of solids 1. And I hope you are ready for this class, that all your notebook and your biro, they are ready to write, and I wish you the best as we start. The objective, before I go on, to find volumes of prisms such as cylinders, cubes, and cuboid. Number 2, cones, pyramids, and compound shape. Example, volumes of prisms generally. V equals base area times perpendicular height. Example of prism is cube. We know that all the sides are equal. So the base is a square, and the height is also the length. So here is h. So here will be h squared. Everything is equal. So example 1. We want to know how many liters of oil does a cylindrical drum of diameter 28 cm and 50 cm deep hold. Here, this is the diameter, and this is the height. So to get the radius, we divide 28 by 2. And this will give us 14 cm. So, volume of this cylinder is pi r squared. So we put 22/7 times 14 times 14, then times 50. That will give us the volume in centimeter cube. But because we want to convert it to liters, we divide by 1000. And the answer is 30.8 liters. That's example 1. Example 2. A cylindrical metal bar, 50 cm long and 6 cm in diameter, is poured out to form a wire of diameter 3 mm. What is the length of that wire? Here, the two objects are both cylindrical in shape. So you know the volume of the first one is pi r squared, and the same with the other one, only that they have different radii. Now, the radius of the first one, which is a 6/2, and that will give us 3 cm. That's big R, because the radius of the first one is bigger than the second one. While the second one will be represented with small r, which is in millimeter. We divide 3 by 2, that will be 3/2 millimeter. To convert to cm, we now divide it by another 10, and it will give us 23/20 cm. So this is the radius of the bigger cylinder. So we know that the volume of the bigger cylinder, which is this, pi r squared, that is pi times 9, that is 3 times 3 will give us 9, then times 50 will give us the same thing as pi r squared here. It will be pi times 3/20 all squared. That would be 9 over 40 times the length, which is L. I represented this, the wire. The length is L. So I will now make L the subject here, and we transfer this one to go and divide this. It will give me pi. We cancel pi first. So I will have 9 times 50. 9 times 50 multiplied by, because we are dividing with 9 over 400, it will now be 400 divided by 9. And this will give me 20,000 cm. 20,000 cm. Converting this one, it will give me 20 meters. That's the solution. The third example I'm going to give for this class, the first part, is an open rectangular box measures externally 32 cm long. Here is 32 cm long and 27 cm with wide and 15 cm deep, representing the height as shown in this diagram there. If the box is made up of wood 1 cm, here is 1 cm, the thickness of this wood is 1 cm. 1 cm. 1 cm. What volume of wood is used? We want to find the volume of the wood here. It is 1 cm thick. Only the upper part is open, while the lower one is covered. So we consider the external dimension. The volume here will be V will equals to the bigger volume minus the smaller internal volume. This is the internal volume. Internal volume now will be 32 times 27. 32 times 27. Then times 15. Then minus the internal. The internal, since it's 1 cm thick, you remove 1 cm here and 1 cm there, it will be 30. Times that of the length, the breadth will reduce to 25, removing 2 from there. Multiply by 14, because the upper height is open. The box is open at the top. So it's only 1 cm we remove from that height. Then we have 14. Then when we multiply that, we will have 12,960 minus 10,000. 10,500. And this will give us 2,460 centimeter cube. But because we are converting it to liters, we divide by 1,000. And this will be 3.46 liters. Now the assignment through classwork is exercise 20C, number 1 to 9, taken from New General Mathematics SS3 on pages 220 to 23. So this is the first part of the lesson. We now move to the second part, that is volumes of solid shapes. Volumes of solid shape. Those the solid shape, they are not prisms. They include a cone, pyramid, and compound shapes. That's combination of shape. Example 1. Find the volume of buckets 24 cm in diameter at the top. Here is the top, 24 cm in diameter at the top. 16 cm in diameter at the bottom, 16 cm diameter at the bottom, and 18 cm deep. The distance from here is 18, which is the height. To do this, we have to complete the cone where you get the bucket. A bucket is a frustum of a cone. So first of all, solution as follows. This is the bucket. We just need the lateral dimension. And why this is the cone that is removed. This is the cone that is removed in order to form this bucket. This is the height of the bucket, and this is the diameter of the top, and this is the diameter of the bottom of the bucket. It will be the diameter of the cone that is cut off from the bigger cone where you get the frustum. Say let the height of this cone that is cut off to be x centimeter. Therefore, by symmetry, first we find the radius of the top here to be 24 divided by 2, and that will be 12. While the smaller radius here, it will be 16 divided by 2, and that will be 8 cm. We call it small r, while the bigger radius we call it big R for the bigger cone, and while that of the smaller cone is small r. Now, by symmetry, the ratio of the radius of the smaller one, of the bigger one, the entire cone, over the height of the smaller one will be the same thing as the radius, of the bigger one over the radius of the smaller one. And that will be 18 plus x over x. It will give us 12 over 8. Now cross multiplying, this 12 will multiply x to give me 12x. Y, 8 will multiply 8 plus 18, it will be 8x plus 44. Collecting like term, taking this 8 down here to go and make 12, it will give me 4x, and we have 44 here. So 4x is equal to 144. Making x finally the subject, we have x equals to 36, which is the height of the cone being removed. Now, the height of the entire, which is capital H, entire cone, will give me 18 plus 36, the height of the smaller one, and that will be 54. So we need to know the height of the bigger cone. Now, to find the volume of the bucket, which is a frustum, it will be the volume of the entire pyramid, of the entire cone, the entire cone, which will be 1 over 3 pi times big R square, and that will be 144 times the big height, which is 54. Then minus the 1 over 3 pi times the radius of the smaller cone times the height of the smaller cone. And this will give me 5,730 centimeter cube. But because we are converting it to liter, we divide by 1,000. And the answer will be 5.73 liters. And that's the solution. Example 2. A solid is made up of a cylinder 20 cm high and hemisphere on top of diameter 14 cm. So we have, that's half half of a sphere. We call it hemisphere. So we have a cylinder at the bottom. I draw it. Then we have an hemisphere at the top, half of it. So the hemisphere is at the top. The radius, this is the shape. The radius here, the diameter here is given to be 14. So the diameter here is 14 cm. So the radius will be 7, half of it. And that's why we have it here, 7. Why this is the height? 20 cm h is the height. So the radius of this hemisphere will be 7. Very good. Now, in order for us to calculate its volume, we have to find the volume of the hemisphere and then add it to the volume of the cylinder. And this is the solution. Volume of this hemisphere will be 22, 2/3, because it's half of hemisphere, pi r square r cube. Pi r cube. This is the volume of this hemisphere. Why we've done that of cylinder, I will go through it again. The volume of this cylinder is pi r square h. So we have it to be this. Will be the first one. Then when we substitute, we have this. And this will give us 3,800. Now 3,800 centimeter cube divided by 1,000, we have 3.8 liter as the volume of the entire solid. That is hemisphere and a cylinder. Example 3. Calculate the volume of a solid made up of coal 20 cm high and an hemisphere. A coal 24 cm high and hemisphere diameter 14. So we have, this is an hemisphere, half of a sphere. It's like a ball, half of it. Then we have a cone at the top. So the diameter here is 14, so the radius will be 7. And the height of this cone is given to be 24. It's 1 meter, 90 there. So the volume of the entire shape is the volume of cone plus volume of the hemisphere. Volume of cone plus the volume of the hemisphere. We know that the volume of cone now will be 1/3 times 22/7 times the radius square, which will be 49, times the height, which is 24, plus that of the hemisphere, 2/3 times 22/7, then r cube. R cube, that's 7 times 7 times 7. It will give me 343. And getting the total now will give me 1,740 centimeter cube. Now, because we want to convert it to liter, we divide it by 1,000. And the answer will be 1.74 liters. 1 0.74 liters. That's our answer. Here are the assignment below. So it's taken from the same exercise, but number 10 to 22 from New General Math on the same pages. More assignments here for you, taken from Further Mathematics Project 1, number 11 to number 18 on pages 155 to 157. And the textbook I've used, they are listed, the references, New General Mathematics, SS3, by Shalom and Co. While the second one is New Further Mathematics Project 1 by Tutu Adeogun and Co. I wish you the best. Thank you very much. So I'll be expecting the solutions of this assignment, and see you next week for the continuation.